Okay, week 10, day 2 is all about division of monomials, binomials, and more. And if we have time, we'll get in some factoring. Yay! Alright, so just to begin here, we talked about on day 1 that if I was doing just regular old multiplication, for instance, that I would have, say, 5 times 2. I need to multiply those together. We should know by now that that means that I'm going to create a rectangle. That's the whole idea, right? Make a rectangle, and it'll be lining up on each of these, on all of their breakpoints. Excuse me. All of their breakpoints should line up, and we would know 5 times 2, whenever I make that, I should get a rectangle. That's a 2 by 5 rectangle. Length is 5, width is 2. And that means that his area is 10, right? 2 times 5 is 10. So for division, what we're going to do is we're going to use the fact that we know that we can work backwards on this, right? What if I knew that the overall area, so area equals length times width, what if I know that the overall area is 10 and I want to divide it by 5? 10 divided by 5. Then what I know is, instead of knowing both of the factors, like you do here, right? 5 times 2 is 10. I know what the actual rectangle looks like there, and I know one of the factors. 10 divided by 5. So somehow I'm going to be able to make this original guy look like a rectangle, which this one's pretty easy, but they won't always be this easy. I'll be able to make this original guy look like a rectangle, and then I'll say, okay, I'm going to divide it up into 5 parts. Well, what does that look like? Now that I've got it divided into 5 parts, that makes 2 big columns there, right? So then I'll come in and I'll fill in the extra factor down here. Oops, sorry. And I'll say, okay, what is it? It's 10 divided by 5 gives me 2. So the 2 is my answer here, right? And we all know 10 divided by 5 is 2. But we can see it lining up there on the columns, right? Okay. So then it becomes, well, what if it was 10x divided by 5x? Okay. It's going to look very similar. So what should go here in quadrant 1? Should be 10x, right? Okay, I'm going to just line them up all top to bottom. Double count myself. I've also seen people make a lot of mistakes on this test by not counting, recounting what you put on the mat. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't want to make that mistake in front of you, right? Okay, so what they're saying is, okay, we're going to do 10x, but we're going to divide it by 5x. So that means one of my pieces here should be 5x, one of my factors, right? Let me go up with it. 3, 4. I'm running out of factor track there. Let me scoot it down a little bit. All right. So I've got 5x, and when I see that, I say, oh, we got a problem, right? My breaking points aren't lining up at all. So I know I want 5x to be one of my factors, so I'm going to leave that on the track. You could put it over here on the horizontal axis if you wanted to, but I'm happy with it there. 5x is good. I don't want to be looking at that problem yet. Okay, so 5x is good, but I know these aren't lining up. So what I'm going to do is I'm going to turn these sideways, right? Or up and down in this case. And so now I'm starting to line up, but I don't go all the way to the top, right? And we know these need to be in 5 groups, basically, 5x groups. So I'm going to start moving things towards the top. Okay, that's better. It's looking more like they're lining up, right? Oh, hang on a second. In order for me to get it into 5x groups here, which is what I'm trying to do to get these to line up, I'm having to make them be kind of really long skinny columns here, right? Okay, so I see that those line up. My breaking points are lining up. Okay, that looks good. So what does that mean across here? I have to match, right? The ends have to match. Well, we know that this x is x units long and what? 1 unit wide, right? Okay, 1 unit wide. 1 unit wide. Do my breaking points line up? Do these breaking points line up? Yep. Okay, that's my 10 x's there. So in this case, I actually don't need the rectangle anymore once I have everything lined up, right? So the 10x was part of the problem. The 5x is actually one of the factors, but what I'm after is what's the other factor? It's on the positive side, positive x. Does that make sense to everybody? So let's double check. Check ourselves. That's a 2, I said. And you can always reverse the process and work backwards, right? 5x times 2 would have been 10x. So yes, indeed, it really does work. All right. So that's the idea we're going to utilize here. It's all still about rectangles, but instead of me creating a rectangle, I actually know that the very first number, my actual, what's that called? This guy's the one doing the dividing. He's the divisor. This piece over here in the boxes, that's the answer, that's the quotient. So what's this guy right here, the first one? He's the one that all the dividing is being done to, right? So he is the recipient, he's the dividend, okay? So the dividend here, that's going to be the area of the rectangle, okay? So I need a rectangle that's 9x squares. 9x squares. Well, I feel like maybe if I kept going out side to side, the problem is this isn't going to be a really long guy, right? Because what? Let me show this. That would be 8x squares. If I put a 9x square on there, what? It doesn't actually make a rectangle, right? Because they've got this little stair-steppy looking thing. It's kind of womper-jaw. Yeah. So 9x won't make 2 columns or 2 rows like what we've been doing. So instead I'm like, okay, so move this guy up, and your whole process is make a rectangle. Is that a rectangle? No. So then I need to move this guy up, and if I move him, I have to move him. Okay, now be a little bit careful here because what I've really got is a square. But if you're in my geometry class, you know that a square is just a really specific kind of rectangle, right? Where the length and the width match. Okay, they're both the same length, same distance. But that's okay because it's still a rectangle, right? Okay, so what I need to be careful of is sometimes that this, with it being an odd number, 9x squared, there's not a lot of ways for me to make this guy into a rectangle. But sometimes, like if that had been 10x squared, there might be a couple of different ways, right? It could be a 1 by 10, a 10 by 1, a 5 by 2, a 2 by 5. So check real quickly and make sure, because they want me to divide by 3x, right? Which means one of the factors is 3x. So he should go on the factor track, 3x. And I'm going to check, okay? Does that line up, all of my breaking points, with the breaking points in the rectangle? Yeah, it does. So that means I think I've got my layout correct. I've got my dividend here. I've got my divisor, or one of the factors, here. And in order to know what my answer is, what? I need to fill in this track, right? And when I fill in this track, am I going to put a lot of green guys down here and start filling it out? No, I'm not going to do that, right? That doesn't line up. What do I need to put there? X. 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 So what's my answer? 9x squared divided by 3x equals 1, 2, 3 x's. Right? I don't need that rectangle anymore. My answer is what's on the factor. What's on the factor track? Well, it's another 3x, right? That's my answer. Okay, so using the same idea, 4x plus 12, divide by 2. a little bit crazy, but we can do it. 4x plus 12 divided by 2. Now I know that I need to make a rectangle out of 4x plus 12. And maybe you're really catching on and you see what kind of rectangle I should be making. But if you're not, bear with me. Okay, I'm making a 4x by 12 rectangle. Okay, and there it is. And that's all fine and dandy. There's nothing wrong with that. But my question is, can I now show on my factor track divide by 2? No, right? I'm going to put this guy on the bottom. Divide by 2. If I divide by 2, I'm good here, right? These guys are fine, but there's extra stuff over here, right? So that's not going to work for me. So what I'm going to do is, I'm actually going to leave those there because it doesn't matter which order I do this in. So I'm going to stick these 2 x's up here, and I'm going to stick these 6 x's or 6 ones up here at the top. Okay. Now are they arranged in such a way that this is one big rectangle? Well, if I don't move my mat too much. Yes. And are they aligned with my factor down here, which is a 1, a 2? Yeah. So that the breaking lines line up right. Yeah. So if that's true, then I need to fill in my factor and I'll have my answer, right? Okay, so whenever I go to fill in this factor right here, I need to be a little bit careful about it because I put all my stuff up all willy-nilly. I need to still make sure that things line up. So for me, I had an x and then a 3, and then an x and then a 3, right? It doesn't matter as long as the breaking points line up, which mine do. It just looks a little funky right there. So some of you, my OCD people, are probably going, oh my gosh, don't do that, it's driving me nuts. Okay, so if that bugs you, it's okay. You can rearrange things. You don't have to put all things all wonky like mine. Okay, so I'm going to line those up and those up. And then I'm going to put these here. I just rearranged what my rectangle looked like. My question is, would this be an okay representation for the problem we're doing? Yeah, the answer is no. Why not? Even though the answer, if I just figured out what this factor is, what is this factor here? It's 2x plus 6, right? That is the correct answer. But if you rearranged your rectangle here to look like this, then what? Yeah, you need to rearrange the factor to look the same way, right? Okay, which most of you probably would prefer to do it like this because now my x's are together and my units are together. It's really easy for me to see. My answer is 2x plus 6, right? All right, so if you weren't sure that that was my answer, you could go back and do the actual arithmetic. And when I give you 2x plus 6. Did I say that? I feel like I said it wrong a minute ago. Sorry. 2x plus 6. There were 6 of them up there, right? Okay. When I give you your problem on your problems for your exam 3, I will shoot out an email with the problems on it to you, your particular problems. And whenever you work these, you're going to have to be able to show me all the stuff and be able to justify what your answer is. You're not just going to show me the answer. You're going to have to actually work through the whole process and explain it to me like you were talking to a child. So I think that that's probably the worst part of this, is explaining to as if you were talking to a child. So just be aware that just knowing the answer as an adult isn't enough. Being able to show it is. So the idea here being, if I divided that guy by 2, it would be a 2. If I divided that guy by 2, it would be a 6. That is my answer, right? Okay, so real quickly, everybody work through this problem right here. X squared plus 8x plus 15. That should be the rectangle part, right? X squared plus 8x plus 15. And then the x plus 5 should be one of the factors. Now, if this looks kind of familiar, it should look kind of familiar because we worked it on day 1. Alright, So I'm just putting on the mat. There's all my stuff. X squared plus 8x plus 15. There's all my pieces. Make sure there's enough of everything in there. I think it is. We'll find out in a second. And then I say, okay, that's my dividend. Make it into a rectangle. Now this is going to require a little more work, right? So we're going to do that. I want to make this guy into a rectangle. So let's see. All right. I know I can arrange these x's in any way I want to. But for instance, if I put them all out like this, the problem is that my unit guys aren't going to line up and break right here. Does that make sense? So you can't just line them all up like that. I know I need to make kind of a hole here where the greens can fit in as part of that partial sum, right? Okay, so I'm thinking something more like this because that's a 3x and a 5x. So because I have 15 there, I'm just using a little bit of my dimensional analysis. I know I've got 15 there, so 3 times 5. But for kids, for high school students, you know, this is not necessarily an obvious thing. So don't feel frustrated with them. Don't lose your whatever, your cool if you go, oh my gosh, what the heck's happening here, right? Because it sometimes takes a little bit of work, and you need to be sure that you can do that process all by yourself without watching me. So maybe on the next one, pause and then do it by yourself and then see what I come up with, right? Instead of watching me do it. Okay, so it was divide by x plus 5, and I'm looking here. I see the x plus 5 is on the bottom. So I'm going to line up my x plus 5 on the bottom. Okay, x plus 5. And then if I've done my job right, hopefully I have, I should be able to see in there, hey, lining up this direction, this piece, how tall is he? And how tall are all of those pieces that line up? They're all an x tall. And then how tall is the next little row here? They're all only 1 unit tall, right? And then the next is 1 unit tall, and the next is 1 unit tall, right? So as I look at that, I say, do my breaking lines add up? Do I start and finish at the same spot? Yes, I feel good about that. So here was my dividend. I don't need him anymore. This was my divisor. I don't need him anymore. What I need is this factor, and it could be either on the vertical or the horizontal, or both. We'll see one in a minute that's both. I just need to know that this is my factor, this is my quotient, that's my answer. So what is it? It's positive, right? X plus 3. All right. So let's see here. Boom. X plus 3. Now, if you were doing this to see the arithmetic, to see how that works out, we actually know this is right because we did it on day 1, right, of this week. So you can multiply back out x plus 5 times x plus 3. See how it multiplies out. You'll get here. Okay. That will be your quote or your product whenever I multiply those together. So it will work out. But if you're not sure how to do that division, you would be doing long division. Or you could do synthetic division if you remember that from your college algebra class. But either way, you're doing some serious dividing here whenever you're doing. This is a trinomial divided by a binomial. So that's why I said monomials and binomials and more, right? Because this is some more advanced. This is like Algebra 2 in high school. So this would be for my people who want to be Algebra 2 people. Now, that doesn't mean that if you want to be middle school, you don't have to learn this. Middle school is going to know stuff like 10 divided by 5, 10x divided by 5x, even some of this little binomial divided by monomial stuff. But it doesn't mean, hey, I can ignore all that stuff because I'm just going to be in middle school. That's not true. You need to know where your students are headed. So you need to know all of this, and you need to see what's going on. I was trying to make up a problem, and I messed up the factor, but that's okay. Here's what I want us to do next. Everybody good with this? Let's move on to this. Work it out on your own. See if you come up with the same stuff I do. X squared plus 7x plus 10. And you're going to divide that by x plus 2. Okay, x squared, 7x plus 10. And you're going to divide it by x plus 2. So stop or rerun the thing if you need to see it. I'm going to work it out real quickly. You work it on your own and then check and see what the heck do you think is happening here. And if you're watching me still, I'm just trying to make a rectangle here. I know that 5 times 2 is 10. So I've got 10 little unit guys here. I'm trying to make match up with these 2 unit guys here. So I've split it into 2x and 5x so that I could have a 2 by 10 rectangle up here. So I see my little partial products coming in here. And now I see, hey, that's going to line up there with a x. And this is going to be 5 to line up very nicely. Okay, so if you stopped it and did it on your own, hopefully you see this when you come back, and that's exactly the kind of look that you've got on your paper or on your algebra tiles, and it looks a lot like that. And we've got x squared, here's 5x, here's 2x, and there is 10. Okay, so I see when I divide it by x plus 2, I don't need my dividend anymore. Move that out of the way. Here's what I need, x plus 5. Because the x plus 2 was my divisor, right? And again, if you're still trying to work those out and figure out what the heck is going on, multiply those together, x plus 2 times x plus 5. You should get x squared plus 7x. Okay, want to make sure we can go into the different quadrants like we did on day 1. So I've got the same 2 problems, but in reverse of what we did the other day. It's going to throw me a little bit off my pattern because I see a bunch of negatives coming in, right? So I've got x squared, I've got negative 2x, and I've got negative 15. Okay. Now, you might be tempted to put the 2x in one quadrant and the 15 in another, but I find that a lot of times it works out better if I can stick them all together like this. So it's a little bit weird because, excuse me, whenever I look at this guy, I see, hey, these 2 x's need to line up vertically, right? But I've got some weird stuff going on here with these units because aside from sticking them just right on top of this x and this x, I'm not quite sure how I need to make those, how I'm going to make those into a rectangle. So what I'm going to do is I'm going to say, hey, let's take a look and say, what the heck's going on here with the x minus 5? That might actually help me. This might throw me into other quadrants. That's okay, but I want to make sure I'm good before I go that far. Okay, I've got an x, and I need to do minus 5. So on this horizontal axis, the minus 5 is going to come way out here, right? So hang on, let me double count my stuff here. I've got a little too much, don't I? Sorry, I told you to always count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I need to make it x minus 5, right? Was what I was after. Yep, x minus 5. So I need a negative 5 over here, I said. All right, here's my negative 5. Now, whenever I start seeing that, I'm going, oh, there's a problem here. My problem is that things don't really seem to be lining up for me. I got extra units here, right? And they're not lining up with that. And I also see, I see that we're having a little bit of an issue with I need more x's, and I have a lot of extra. Like, for instance, I've got these lined up here. I've got a lot of extra unit guys going on. I've got these lined up here, and I'm seeing, hey, they're not lining up with anything, right? So in my brain, I'm thinking, oh my gosh, I know x minus 5 is a factor, so I know stuff's got to be lining up there. So what the heck could be happening here? Okay, and if you think back, this was the problem on day 1 where there were 0 pairs. Okay, if you remember that far. If you don't remember that far, it's fine. But the fact that I need to put more unit-wide things here and I don't have them, I need to fill in this gap, basically, is what I'm saying. 1, 2, 3. Because this x minus 5 guy is definitely one of my factors, so it's got to line up here. But in my brain, I say, well, gosh, I just changed the problem because I put in a negative 3x, right? Okay, so if I'm putting in a negative 3x and I want to make that balance, what? I need to put in a positive 3x. And notice that I'm lining it up over here on the positive quadrant so that it all lines up nice and pretty, okay, with the x squared. Okay, so if I put in that positive 3x, let's double check ourselves. Negative 3x, positive 3x. That's what I started with. I'm going to do this. That's adding 0 pairs onto the mat. I'm okay here, but now I need to deal with my units. Is that okay? All right, so now I'm thinking, oh, well, these have to line up with this end and that end. So they all need to be 1 by 1 blocks. And in fact, I went too high here. Do you see that? That's not lining up with anything over here. So I need to move these over. And then lo and behold, look at that. Ooh, it's like magic. Got a little bit of a goosebump there. Okay, so my arms, ooh, magic. So when I see that, oh, that does look a lot like a rectangle, right? 2 rectangles, but if I squished it together, it would be 1 big rectangle. Alright, so the trick here is I had to add 0 pairs, and I have to make all that look like 1 big rectangle. That's my dividend. Here's my divisor. I need the quotient. Where do I find that? It's going to be one of my factors. Is it this horizontal one? No, that was my divisor. So it better be this vertical one, right? So I just need to fill in that factor track and make sure things break at the right points. So this piece right here needs to be an x. Does that break at the right spot all the way across? Yeah. And then what do I need to fill in there? 3. 1, 2, 3. Does that line up everywhere? All of my pieces are breaking correctly? Yeah. So what I see is, once I move those pieces out of the way, my divisor was x minus 5. My quotient is x plus 3. Right? Okay, and we all see how that threw me into quadrant 2. And I had 2 different rectangles going on there, right? 2 little partial products. So I can still work it out, but it's going to throw me off out of quadrant 1. I'm not just going to be in quadrant 1 anymore, right? Alright, and the last problem, we're going to work with these division problems. Again, we saw this one last week, but I felt like if we redid it, but working the other direction, maybe it would help us. So here we go. The dividend is x squared minus 8x plus 15. Okay, plus 15. And as I line these up and start making them into rectangles, I know this is my dividend. It needs to look like one giant rectangle. Immediately I have a problem, and my problem here is that these units up here will not line up anywhere with this x squared, right? So, but they will line up with the ends of these x's. So I need to move those. This is where it's going to cause me to go into other quadrants, and that's okay. I need to move those and make a little partial product rectangle down here that lines up better with what the heck is going on in quadrant 2. So I start doing this. My problem here is what? Like, this is lining up better. My breaking points are much better. I have 2 problems here. One is that this isn't a rectangle, right? It's got a little missing piece, or if you want to think it's got an extra piece, whatever. But it's not lining up there. And the other is, if I take this away, overall I don't have a rectangle, right? I'm going to have a little missing piece over here also. So this is going to kind of stair step here, and I'm not going to be able to shove them together and make one big rectangle. So the trick here to remember is if you're working a problem and you suddenly get to where your problem throws you into 3 quadrants like ours did, guess what? You can't just work in 3 quadrants. You can work in just 1, or you can work in 2, but you can't just work into 3 because this makes it not a rectangle. So as soon as I go to 3 quadrants, I know, hang on, there needs to be a piece over here. So think about it. I need this to be one big rectangle. This is never going to be a rectangle unless I have a piece in the 4th quadrant here, right? All right. So what I need to do is move some stuff around a little bit. I'm just going to grab 3 of these. Notice that when I grab them, I turned them so that they're lining up here on the X's and they're lining up this direction on the 1's, right? So let me see if that works for me as I move these around. It should, I think. If you weren't sure and you only moved 1 or you only moved 2, what you'd soon find out is these aren't making rectangles until I have 3 of them, right? Now that looks nice and pretty, right? All my breakpoints are lining up nicely. These are all X's. These are all X's. Those are all 1's. That's good. Hopefully I have a little bit more to go on also. If we weren't too certain, one of my factors should be an X minus 3, right? X minus 3. I don't have anything filled on my factor tree, so let's do that. X minus 3. Does everybody agree? 1, 2, 3. Okay, so we can see, hey, that's lining up really nicely. We did a good job creating our rectangle. So what should the other factor be on the other factor track? This is definitely an X. And this should be what? 1, 2, 3, 4, 5 of them, and they're all negative. Does everybody agree? So actually it throwing me into 3 quadrants is not so bad. Because when I look at it, hey, there's my dividend, 1 giant rectangle, if it didn't move too much, that's all good. We feel good about that. No worries, so that worked out nicely. And then I had X minus 3 given to me, so I know that the quotient or the factor that I'm looking for is X minus 5, right? Okay. So here I go with X minus 5. That's my answer. Okay. So the interesting thing for me, let me pull this down and we'll look at it. And I'm just going to start you on the factoring piece because I see that this video is already almost 33 minutes. So the interesting piece is when we're doing a division problem, it's actually kind of nice because they give me the dividend and they give me the quotient, or I'm sorry, the divisor, right? And I'm just looking for the quotient. So that actually is kind of nice because I have 2 pieces. But think about whenever they say factoring a trinomial. Factor, let me find an example, I'm sorry. Well, let's just pull this one, x squared plus 7x plus 10. Factor x squared, we already did it, it's right here. We know that that's what? The trick is they're not going to give me the divisor, right? They just give me the dividend, basically. Factoring is the same process as division. It's just that they don't give me the divisor, so I don't know what it is. Now, if you're really good with your factoring, again, when I give you your problems, you can kind of play with it a little bit, and you can go, oh, I know this is what my answer should be. And I would say, as an adult teacher walking into a classroom, working with high school students or middle school students, I try to always work out my problems in advance so that I know what the answer looks like. But I'm not telling them, right? I'm not going to say, oh, the answer is x plus 2, x plus 5. I'm going to know that answer, and I'm going to have it maybe in my notes off to the side where I can compare later. But as I start working this problem, I'm not going to tell them, hey, the answer is this. I'm just going to say, hey, we're supposed to be doing x squared, plus 7x plus 10. Plus 10. Boom. Factor it. Okay, now there's lots of factoring techniques, and whatever technique you're using, trial and error, AC, box, lightning, move it to the back, whatever, I don't care. You can use whatever technique you want. But I'm telling you that they need to be able to factor this using Algeblocks because your students are going to see it. First of all, it's good conceptual for them to see how does x squared, why do we call it x squared? It's because it really makes an x. The x's really make squares, okay? But then to see what's the actual concrete model for what's happening here, okay? So it's good for them to all see that. As I'm looking at this, I'm saying to myself, okay, you're asked to factor this. You need to make a rectangle. This guy's not going to work because those will only line up with the ends of the x's, right? So I will just start grabbing one or two and say, will that work? Nope, that's not going to line up because that's a 6 by 1, right? And I got all these leftover guys, okay? Will it work if I move 3 of them? Kind of cheating because I know what the answer is, so I'm skipping it. Okay, no, it doesn't work if I move 3 of them, right? Because then I've got a little gap up here, sorry. A little gap up here in my rectangle, right? It doesn't line up. I need my factor track to line me up, even though it's not working right. There we go. Okay, so I've got that little stair step that's cut out. So I went too far. Before there were extras left over, now I don't have enough. So I need to move this guy back down here, and these two can move to line up perfectly with the end of that. Okay, and now because I'm factoring and they didn't tell me what the divisor is, I need to tell you both things that go on the track, right? So let's see, that's an x plus 5. And going vertical here is an x plus 2. So if they give me x squared plus 7x plus 10 and say factor it, then I'm going to create a rectangle. You're going to draw that on your pictures on your homework, and then I'm going to figure out what the heck goes on that factor track. So my answer is here, x plus 5 times x plus 2. And what you'll see is the same stuff happens if they suddenly throw me into a negative, right? So no big deal if they say, oh, this is a negative, blah, 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 it's okay. It's just going to make me go into either 2 quadrants or 4 quadrants. But you're going to know it's not taking you to 3 quadrants, right? So no big deal there. All right, so that's the difference between factoring and division. Is literally for the division, it's actually a little bit nicer because they give me the divisor. Here I have neither factor is given. Instead, you're going to make a rectangle and determine the dimensions or the size of each side, i.e., oops, sorry, I know I'm out of space here, i.e. the factors. That's what we're going to do. So that's your process if you need a factor instead of divide. Just make a big rectangle out of all of them. You're going to be in 1, 2, or 4 quadrants. Make a rectangle no matter what, and then determine the size, the dimensions of each side, and those will be the factors. So real quickly, just one more so that we can see what's happening here. Let's do this other one that we had worked out up here. X squared minus 8x plus 15. We already know the answer whenever we factor it. It's x minus 5 times x minus 3. However, what's that going to look like if I don't know for sure one of those factors? X squared minus 8x minus 15. Was it minus 15? I'm sorry. Let me check again. Plus 15. Okay. 1, 2, 3, 4, 5. We already did this one, so we have a feeling for what it's going to look like, right? I think I know what it's going to look like. Okay, so here we go. There's my x squared. It should have been like a 5x and a 3x, right? Okay, fill it in, fill it in. It's not always going to be this easy because it's not always going to be a problem I just worked. But you'll make your rectangle, make a big old rectangle. There we go. And then we'll tell everybody the dimensions. What is it? X minus 5, x minus 3. Right? So we can do it even without giving the little hint of what the factor is going to be. All right, that's it for this week. Just a minute, I'll give you the housekeeping video, and you'll be a wrap. Thanks.